There you go.
Okay, there we are. Well, hello everyone, and welcome to the Humans and Wildlife Show. And this time it's a little bit exotic, a bit unusual, because my co-host Dr. Georgia Oteri, is actually at the airport, just about to fly, and I hope there's not too much surrounding noise coming in from building at the moment. So hopefully this will go well. Very nice to see you all. Georgia, can you just say a quick hello?
Yeah, hi everyone. Yeah, I'm at the airport right now, and so I'll just be around for like the very first part. And so most of today's show is pre-recorded though, and so yeah, I wanted to give a little mini introduction to the topic today. So we are talking about fruit bats in India, correct, Christian? And our guest today, who we pre-recorded the interview with, he talks a lot about the bats there. And so I just wanted to take a minute to orient people to them. So there's three main types of fruit bats that we're going to be talking about. The first is these tent roosting bats, or sorry, the tree roosting bats, these bats that just hang in the leaves of the trees. The second is the cave roosting bats, and then the third is tent roosting bats. And so sorry for the background noise, but yeah, so basically these three types of bats, they all eat fruit, but the tent roosting ones especially are a little bit hard to understand. So these are bats that hang out in the leaves of the tree, and they so these little white bats here, basically what they've done is they've chewed along the vein of the leaf, and when they chew along that main vein, it causes the big leaf to like collapse. So these tent making bats, basically they're creating roosts for themselves where they can sleep during the day in a little like artificial tent made of the plant. And we'll also hear these tree roosting bats, these big bats that just hang in the leaves of the trees. They're also sometimes called flying foxes. So you might hear them referred to that way as well. And then something cool about the cave roosting species is they often can live in things like buildings and, oops, not that. Where is the picture? Yeah, the cave roosting species will often live in buildings as well, because if you think about it, buildings have lots of crevices and stuff that can be kind of like a cave. So that was just our quick visual orientation to the different types of fruit bats that occur in India and many other warmer places of the world. Christian, you're muted still. There you go.
Okay, thank you. Sorry, I was on the background noise. Thank you, Georgia. That went very well, despite being at the airport. That's very good. So the interview was recorded yesterday, and we actually added subtitles very quickly to aid you to read it. So the subtitles are not perfect, just that you know. I hope we haven't even had time, but we inserted them so that you can follow, because actually the content
Attention
is
passengers,
absolutely
due
amazing.
to an increase in the
And
airport security level.
I'll just mute Georgia for 1 second. It's really interesting. What's also fascinating, I mean, I didn't even know that there are bats that don't use echolocation, so they don't actually use their sonar system for locating. Fruit bats don't need that, and Georgia can tell you, of course, much more than I can. But it's just important to note that their visual perception, also their sense of smell, is really what this is all about. Anything you want to
Yeah,
add?
and their eyesight as well. So you can see, like, if you look at some of these pictures, you can see that the bat's eyes are actually really big. And that's because I always like to say fruit don't put up much of a chase. It's easy to catch the fruit, so you don't need that sonar or refined echolocation. If you have decent night vision, you can find the fruit pretty easily. So yeah, thanks everyone. Sorry, I have to run real quick because my flight is finishing boarding now. But just to answer a couple questions here, I'm on my way to my friend's wedding where I'm going to be a bridesmaid. I'm so excited. And the three types of bats for a gentleman ghost, or sorry, no, sorry, that I imagined that question. The huge ones are flying foxes, yeah, and they're one of the tree roosting bats. We have the tree roosting bats, the tent making bats, and the cave roosting bats. So we're going to hear more about them, yeah.
Very exciting. Thank you so much, Georgia, and thank you, David Dunn, for the super sticker, and thank you for everyone being part of it. So we're going to jump right in the interview. I'm going to share that now, and well, let's wish Georgia all the best. Have a wonderful wedding. So she's in airport, Detroit airport. Yeah. So she's very close to Canada, and she's flying even closer to Canada, to Minnesota, right? So
Yep.
that's
Bye, everyone. Enjoy the episode.
okay. Bye bye. Have a good flight. Okay. Right. Okay. Well, I'll take it from here, and I'm going to do my best now and I'm absolutely no substitute for Georgia, especially when it comes to bats, but I'll certainly do my best. And thank you for sticking around. So this is quite an amazing interview. That's what I can tell you. So I'm going to share that now. Okay.
With us today, we have the very soon about to be Dr. Bahirathan Murugavel, and he is just finishing his PhD at the Indian Institute of Science, Education, and Research, and he's handed in his thesis, his dissertation, everything, so that means he's like just about there. So, about to be Dr. Murugavel, why don't you introduce us to, what do you study?
Yeah, so hi everyone, thank you for inviting me in the show. So yeah, I am Bahirathan Murugavel. So I'm a final year PhD student in the Indian Institute of Science, Education and Research, Thiruvananthapuram, Southern India. So for my PhD, my major focus was visual ecology in this non-echolocating family of bats, the fruit-eating bats. So out of all the bat families, there is only this one family called family Theropodidae, which consists of species which do not echolocate. So all the other bat species are known to produce this ultrasound echolocation through which they navigate. But there is this group of bats which predominantly rely on vision and olfaction for their navigation and orientation. So I studied the visual ecology of those animals for my PhD. So in India, there are more than 130 species of bats, out of which we have 12 species of fruit bats, and each have their own habitat and roosting ecology per se. Roost is the place where bats spend their time in the day. And for my PhD, what I did was I took 3 species of fruit bats, all sympatric, which means they share the same habitat, and I compared their vision. So what is different among these 3 species is their roosting ecology itself. So I chose one species which roosts completely inside dark caves, and I also chose one species which hangs in open trees, which is the flying foxes, which you can see in large numbers. That's one of the biggest bats found in the world. So there is this extremes of dark versus bright roosting species, and I also took a tent making species, which means they do not completely roost in darkness or brightness. So they make these animals alter plant foliage, and they make this tent kind of structure, which is exposed to kind of intermediate levels of light during the day. And I compared how vision differs in these 3 species. So
that's so cool. Yeah, and so just as a quick recap for people, because most people I know aren't very familiar with bats. So these fruit bats, unlike a lot of the bats we think of, like you were just saying, they don't use the sonar, they don't use the echolocation as much, because fruit do not put up much of a chase. You don't have to use this high-tech ultrasound to find the fruit. You can just look for it, smell it, and then grab it. So these fruit-eating species of bats actually have very good, from what I understand, they have better eyesight than we do. Is that correct? At least at night.
Yeah, in the night they can see better than us. Yeah.
Yeah. And you were talking about the roosting ecology, and that's just what bat biologists use to talk about where is the bat sleeping, hanging out, basically. When it's not flying around, where is it chilling? And often this is, during the day when the bats are sleeping. And so this is a really cool link that you've made, because you're like, okay, some of these bats hang out in caves where it's very dark. Some of them just hang in the trees where it's very light during the day. They're exposed to the light. And then some of them are in this in-between thing where they basically, from what I understand, and you can correct me, they have the tent-making bats you were talking about. If you have a big leaf, they often chew along the vein of the leaf in the center or something, and so this big leaf will kind of collapse, and then the bats will hang in they'll hang upside down in the collapsed portion of the leaf, correct? Yeah. And so was I'm gonna guess your hypothesis
is your hypothesis that like the bats that hang out in caves are the most sensitive to human sources of light, like light pollution at light, like street lights and stuff like that, and the bats that are in the trees are less sensitive to it? Or is it the reverse?
Yeah. So that was the not just artificial lighting. First, I started with natural lighting itself per se, the moonlight and even the twilight timings. So when they emerge out and things like that. Yeah, basically what you said was my working hypothesis. I was trying to see which is more sensitive and which is not. And I also took an anatomical approach where I estimated their spatial resolution using their retina, and basically try to estimate at what distances they could resolve objects. Is there a difference between their roosting ecology and their visual modalities itself?
Do you mean just like how far away they can see the objects?
Yeah, how far they can resolve objects. Yeah, based on their retinal anatomy, it was like I was trying. That was one part.
Any questions, Christian? Or
yeah, actually, yes. I find this very intriguing. Well, first of all, because I come from an astronomy background, so the word light pollution means something different to me than to you. But anyway, I just to go a little bit broader. I read on this one Zoom. I'm always interested to see, where all these bats come from. I found there are about 26 species of fruit bats. Are all these fruit bats similar? They have no echolocation abilities. Are they all the same, or are they different again?
Okay, so there are two families of frugivorous bats per se. One is in the old world fruit bats and the new world fruit bats. So the one which I'm talking about is the old world fruit bats, which comes under the family Theropodidae. And and the new world fruit bats, frugivorous bats, it comes under the family Philostomidae. Philostomidae also has a diverse group of bats which feed on a variety of things. And a part of some of the species in that family also are frugivorous, and they are present only in the new world. So these are the two families which are,
I was just saying, Christian, I'm writing these words down in an email for you so you can share. A lot of times our audience wants to know how things are shared or spelled, and so we, like in the chat, we can put it out so it's spelled easily for people. Yeah. Sorry, I didn't mean to interrupt.
And also because I studied optics, I'm very interested in you talked about the retina and their visual perception. How does it compare with a human being, or are they also able to see a little bit more on the near infrared? And what type of spectra are you talking about? Hello?
Did you hear that?
Yeah, at this stage we lost him for a moment. Maybe we lost him. He'll come back. Yeah. Can you hear us? No, I think he's lost us. Okay. Okay. We'll wait.
Yes. Oh wait. Well, I'll share my one.
Okay, I'm just spooling a bit forward. What they see and what they don't see, is it specific for the fruits that they eat, or how does that work?
Okay, so in the retinal perspective, bats mostly have a rod-dominated retina. So they might, there are cones, but it is not that good as the diurnal animals like primates and humans. So in the day, if you take, humans will have a better vision, and sensitivity will also differ accordingly. But in the nocturnal point of view, it is so since they have a rod-dominated retina, they have adapted for the nocturnal vision, and in that case, they are better than humans in the night vision aspect. But they have color vision studies are very much sparse in the bat world. But so there are evidences of they having cone photoreceptors and stuff like that. But still, there is so much to explore in this avenue, especially.
But if you look at the rod response, is that more into the blue then? Because usually our rods are a little bit more blue responsive than they are sort of yellow-green response. Do we know something about that? Or, with the sensitivity actually of their night vision? Is there?
Yeah. There is differences between species and families. So for fruit bats, yes, they have rod-dominated vision. They have rod-dominated retina, and so sensitivity-wise, there are very few studies. So I cannot exactly remember the actual information about it. But yeah, so there is so much to do in that. But yeah, very much information is not that available for that field for now. Yeah.
So you mentioned that you had some slides to share with us. Would you like to share those now?
Yeah, so first I wanted to say, I started with understanding how these three species respond to natural lighting, and interestingly I did find the cave roosting species prefers darker time points. So they tend to come out in astronomical twilight, while the other two species were starting to fly out in civil twilight, and they completed their flight activity in the early morning also by in the darker time points. It was the dark roosting species was trying to finish their flight activity in the darker time points. That is when I started thinking what will happen if they are exposed to artificial light, because all these three species are known to roost in urban habitats. They're very much urbanized, and they're exposed to constant levels of artificial lighting. So I did compare how roost light exposure affects their emergence and return activity in the cave roosting species and in the flying foxes. So again, we did find a species-specific response. For the cave roosting species, what I found was emergence was significantly delayed in the light-polluted colony. So that is what I shared some photos also about the light-polluted roost. So
that means the one species that roosts in the cave, it tends to come out later when there's more human light pollution.
Yes, yes. Even though in the natural conditions it was coming out late than the normal flying foxes and the bright roosting species, but when light pollution comes into the picture, it was even more delayed.
Yeah, just to clarify, because you're using some actually very good